In today's video, we are going to be solving one-step equations. Specifically, one-step equations that need to be solved through addition or subtraction. Now, one of the 10 commandments of math that is on my cabinet door over on the side of the room is that whatever thou shalt do unto one side of an equation, thou shalt do unto the other. And until now, that might not have made too much sense, but after today, it will. The idea of solving an equation is to, and this is going to sound very fancy, isolate the variable. Isolate, we all know from our COVID days, means to be alone. So the letter, wherever it might be in the problem, wants to be alone on its side of the equal sign. So let's look at number 27 here. We have n minus 19 is equal to negative 33. And I'm going to draw a line down through the equal sign. And this is just to make sure that whatever I do on one side of the equal sign, I do on the other. The n really wants to be alone, but there's this negative 19 there. So the question is, how can we make the negative 19 disappear? What is the opposite of minus or negative 19? The opposite of a negative number is a positive number. So what's the opposite of negative 19? It is positive 19, which also looks a whole lot like addition because it is addition. So if I put a plus 19 on the left side of this equation, that negative 19 and positive 19 will cancel each other out, leaving that n alone, which is what he wants to be. But remember, whatever we need to do on one side of an equation, we also have to do on the other. So negative 19 and positive 19 will cancel each other out, leaving our n by itself, which is the goal. On the right-hand side, we have negative 33 plus 19. Okay, this is using our integer rules. They have different signs, so we will subtract the numbers. How do we get, what's the difference from 33 and 19? They are 14 apart. We keep the sign of the bigger number. 33 is bigger, so we keep its negative sign. N is equal to negative 14. In number 28, we have negative 8 plus n equals negative 25. And again, our n would really rather be alone. So we've got a negative 8 that we need to cancel out. So what's the opposite of a negative 8? The opposite of a negative 8 is a positive 8. So if I add a positive 8 to the left side of this, the negative 8 and positive 8 will eliminate one another, again, leaving that n by itself. So whatever I do on one side, I must do to the other. I must keep the equation balanced. Again, the negative 8 and positive 8 get rid of each other, leaving our n alone. What's on the right-hand side? Well, using our rules, negative 25 plus 8. Okay, different signs. 25 minus 8 is 17. Keep the sign from the bigger number. 25 is bigger, 25 is negative. And number 29, variable moved over to the right side. It doesn't matter. What matters is what's over there with it. It's a negative 16. So how do we get rid of the negative 16? What is the opposite of a negative 16? It's a positive 16. And whatever I do on one side, I must do on the other. The negative 16 and the positive 16 will get rid of one another, leaving just the r, which is what we want. What is negative 2 plus 16? Well, subtract them, because they're differently signed. 16 minus 2 is 14. Keep the sign from the bigger of the two numbers. 16 is positive. Number 30, m minus negative 4 equals -2. Yes, if you are wondering, did he just slow down? He did. Did he deliberately emphasize the minus negative? He did. Do you remember what that means? I really hope so. You must recall from our work with integers, anytime we saw minus negative, we immediately rewrote. Remember, minus negative gets replaced with plus. So m minus negative becomes plus. 4 equals -2. Any and every time we see minus negative, we're going to clean it up. Now, we have our equation. We need to know what to do. So what's hanging out with m? It is a +4. How am I going to cancel out a +4? With a -4. And whatever I have to put onto one side of the equation, I must put onto the other. So if I have to put a -4 with the left side, I got to put a -4 with the right side. Again, by design, +4 and -4 get rid of each other, leaving that m all alone like it wants to be. And on the right side, we have -2 and -4, or -2 minus 4. These have the same sign. They're both negative. So we keep that negative sign, and we add the numbers. 2 plus 4 is 6. M is -6. At this point, you've seen an example of everything I can throw at you in terms of a basic equation. So I invite you to pause the video and take an attempt at 31 to 34. Then come back to the video and see how you did. In number 31, we're trying to get rid of a -7, so that requires us to use a +7 to make that happen. Gets us the solution that 7 is equal to r. In number 32, we are trying to eliminate a +10. The opposite of a +10 is -10. And we get a solution of 4 being equal to p. In number 33, we're trying to eliminate a -1. That will require us to add 1 on both sides, getting us a solution of r being equal to -5. And for number 34, we're trying to get a -1 away from x. That requires us to use a +1 to make that happen. -8 plus 1 is -7. Yes, there are word problems. They are not to be afraid. What we're going to be doing is setting up one-step equations for addition and subtraction and then solving them. So let's take a look at this. Ryan is cooking a cake. The recipe calls for 5 cups of water. He accidentally put in 8 cups. How many extra cups did he put in? Okay, so what do we know? We know that he put in a total of 8. We know he put in some extra, and we know what the recipe called for. So the recipe plus what he put in extra would be the total. So, what's the recipe call for? 5 cups. How much extra do we put in? Well, that's what we're trying to figure out. How much total did he put in? 8. Solving this equation requires us to eliminate a +5. We do so with the use of a -5, and the amount extra is 3. Now I want to point out, some of you are probably thinking, okay, Mr. Noy, I don't need to write an equation down to do this. I can just tell you it was 3 extra cups. And you're right, I understand that. That's not the purpose here. For these problems, and there will be problems like this on the quiz, you are required to give me an equation and show me that you solved it. If you do not do so, you will not get points for the word problems. And this is not me trying to be mean or cruel. This is me trying to help you prepare for the PSATs, the SATs, any standardized testing you wind up taking. There will be times on those where you must not just give an answer to a problem, but be able to show where it came from. And this is your introduction to that. Number 36. Shanice ran 30 miles less than May last week. Shanice ran 19 miles. How many miles did May run? Okay. So Shanice ran 30 miles less than May. So let's turn that into an equation. Shanice is 30 miles less than May. Going way, way back to our first lesson, 30 less than May means we have to have May's value and take away 30. Now, one of these two people we know, Shanice, she ran 19 miles. So I can replace Shanice, her S, with 19. And now, okay, we have an equation. Let's solve it. We're trying to eliminate this negative 30, so we're going to add 30 to both sides and get 49 equals M. And the question is, does that make sense then? Because our answer should always make sense in terms of our problems. So Shanice ran 30 miles less than May. That means May has to run more than Shanice. And this is clearly showing us May running quite a bit more. Number 37. Cody will be 75 years old in 7 years. How old is he now? Okay. So we don't know his current age, which we'll use C for Cody. But we do know in 7 more years, so if we add 7 to his current age, he will be 75 years old. Now we have ourselves an equation we can solve. We're trying to take care or eliminate a positive 7. That requires us to use a negative 7 on each side of our equal sign. And that means our C, Cody's current age, is whatever 75 minus 7 is. And that, my friends, is 68. And number 38, we're back to cooking. Sumali is cooking pancakes. The recipe calls for 4 cups of flour. She accidentally put in 8 cups. How many extra did she put in? So this is much like 35. If you'd like to pause the video and try to do this the same way I did 35, feel free. But we have whatever the recipe calls for, plus the extra, being the total amount she used. Recipe calls for 4. We're trying to figure out how much extra. We know she used a total of 8. We are trying to get a positive 4 away from E, so that requires us to employ the use of a negative 4. And the amount extra is 4 cups.